Hi, my name is Joy Orhn. I am here to talk about our lab where we labeled our skeletons. And the good thing about the lab for labeling our skeletons was that it helps us to remember um, not only the names and the positions of the skeletal bones, but also the function of each bone. For example, the skull, we have lightweight plate bones that protect our brain, but we also have sinus cavities in our facial bones that make it so that the bone is more lightweight and not so heavy. Our cheekbones and our jawbones and our teeth are also contained here. One of the nice things about the way the bones are named is that it also helps us remember the different lobes of the brain, since they're all named the same. From there we have our cervical, which supports our whole body. The spinal column supports our whole body. The cervical supports our head. It's our neck. It makes it so that we can turn our head from side to side or look up and down. From there, the thoracic vertebra support our rib cage, and then the lumbar vertebra support everything above it, which is why they're a heavier, more dense bone, because they're bearing weight. Our rib cages support our internal organs as well as our sternum, and they also have our support where our clavicle and scapula are attached, and from there our arms are articulated to the clavicle and scapula. Our forearms are the radius and ulna, and they allow us to turn our hands, turn our arms, and they are attached to the humerus, which is the long bone of the arm. The long bone is heavier and longer and has muscles that make it heavier and longer by the resistance and the pulling from everyday activities. Our hands consist of the carpals, metacarpals, and phalanges. The carpals are our wrist bones, which allow mobility and flexion, extension in our hands. Metacarpals are the bones of our hand that don't move a whole lot. They are attached to our phalanges. Our phalanges are our fingers, which we use for picking things up, holding things, grasping. Our pelvic bone is attached to our spine. It is also a support system, and our legs, starting at the femurs, are attached to the pelvic bone. The femurs are the longest, they're the strongest, and they're the heaviest bones in our body, and that is because they bear a lot of weight from basically the whole body up. They have large muscles that pull on them or push on them depending on the amount of exercise we do. So somebody who does a lot of weightlifting is going to have a lot heavier, thicker femur bone than somebody who doesn't do any kind of exercise. From there we have our knees, which are patella bones, and just below the knee are the tibia and fibia. The tibia is the heavier of the two bones. The fibia is kind of like the ulna or the radius on our arms. It's just kind of more support, helps with flexibility, turning. Attached to the tibia and the fibia are our ankle bones, and they are called the tarsals. They're the equivalent of the carpal bones in our hands, and they also allow for mobility and range of motion in our ankles and in our feet. And then we have our phalanges and our metatarsals. The metatarsals are the longer bones in our feet, and they are the equivalent to the metacarpals in the hand, and the phalanges are the equivalent to the phalanges in our hands, but they are our toes instead of our fingers. Overall, our body kind of works without even knowing that it's doing most of the work that it does. It's come second nature. We don't even realize that we're using our arms to pick things up, or twisting our necks to look at things, or bending over at the waist. We don't realize a lot of times when we're squatting to pick things up. And this is all just kind of a grand design. So this lab was very good for me. It helped a lot with actually remembering a lot of things that maybe I had forgotten in the past, and helped a lot with when we took our tests. So I think overall it was very beneficial. Thank you.